I'm Luke Hoban, CTO here at Pulumi, and I'm joined by my colleague Mitch, Solutions Architect on the team. So one of the things when we think about sort of best practices for infrastructure as code, one of the things that we sort of deeply believe here at Pulumi is that infrastructure as code best practices are really all about applying the best of software engineering to the problem domain of cloud infrastructure. I'd say over the last 4 decades, we as an industry have kind of learned how to scale up the sophistication, complexity, and value of what we can build using software. And those lessons are things that we're now going and applying into how do we take those and apply them to cloud infrastructure as we need to scale up the complexity, sophistication, and value we gain from our cloud platforms. And while the concepts of sort of software engineering are typically the same kinds of concepts that are going to apply in infrastructure as code, the way that those are applied to infrastructure tend to be somewhat different and have some unique characteristics specific to that domain. And so in this talk, we'll look at both some of what those software engineering practices are and how we can think about applying them into infrastructure as code. So I'm going to break down the talk around sort of 3 different domains in which we can think about applying our infrastructure as software best practices. And those are at the scope of the individual developer, and how do we enable the developer to be productive, to have the capabilities they need, and have the flexibility to develop the solutions they need quickly. The second is going to be teams and how we can enable a team to work together effectively to enable reuse, best practices, and confidence in their ability to deliver solutions quickly. And then the last is going to be at the sort of organizational level. How do we maximize the consistency, the standards, the ability to evolve infrastructure over time, and to scale up the use of infrastructure across the entire organization, empower everyone in the team to access and use rich cloud infrastructure. So let's dive in first on the developer side. So probably the most obvious best practice is to really take advantage of the fact that infrastructure as code is code. And this really is a fundamental benefit, a fundamental shift in mindset from the sort of traditional way of working with infrastructure, where we jump into a portal, we point and click, we provision some resources, and now we don't have repeatability, we don't have the ability to sort of evolve that, we don't have written down anywhere what our infrastructure actually is. And so by using code, we get the benefit of writing down our infrastructure, making it repeatable. When we want to stand up a new environment, we already have the code that describes how to do this. All we have to do is provide some separate configuration for that new environment. Of course, because it's code, we can also bring to bear all the software engineering tools we're used to around our code. We can bring our IDEs and the productivity they offer, the error checking they offer, and all the libraries that are available in our language of choice to leverage as part of our infrastructure as code solutions. Now, effectively managing secrets is important for all sorts of software projects, but it's especially important when working with cloud infrastructure. Because cloud infrastructure typically involves many highly privileged environments, credentials that have access to lots of things within our cloud environment. And so when we're working with our infrastructure, we really need to make sure that we're managing our secrets effectively and safely. With Pulumi's first-class support for secrets, you can make sure that any sensitive data that's entering the system is treated as being secret, and made sure that throughout the lifetime of how that's handled in the program, it's maintained as a secret, even if it's modified along the way, like we take a secret input and do some concatenation with it or something like that. That value will never leak out as a non-secret value. And also that we can then make sure that that's encrypted and stored in a safe way in any place where it's serialized outside of the Pulumi project running. And of course, with customer managed keys, we can allow you to have end-to-end encryption of these values so that even the Pulumi service doesn't know about the values of these sensitive pieces of data, and that nothing that's being stored in any serialized format has access to these. And so take a little bit of a look at how developers can benefit from some of these infrastructure as code best practices around code, secrets, and productivity. Let me hand it over to Mitch to do a quick little demo here of Pulumi infrastructure as code in action. Mitch.
Thank you, Luke. As Luke was saying, it is software engineering applied to infrastructure as code. And one of the fundamental concepts there is really around DRY, right? Don't repeat yourself. And we're going to talk about sort of varying variations on that theme as we go through these demos. But the first one is really around, our basic constructs of a project and a stack. So here I'm looking at a pretty straightforward project. It stands up a VPC, creates an RDS security group, RDS subnet group, and then an RDS instance. And this is my code base. This is what I can manage and use and write once. And then I instantiate that into multiple stacks. So for example, I have a dev stack. In my dev stack, I don't want to use multi-AZ for my RDS. I want any changes to be applied immediately. Whereas my prod stack, I'm going to override some of the defaults that I have in my code around instance size, and I do want it to be multi-AZ, for example. So this fundamental idea of having one code base that then gets instantiated as different environments is sort of that first level of don't repeat yourself approach that Pulumi enables. Now, also, since I'm using a programming language, I'm also able to apply very basic approaches around just breaking up my code to be more readable, more maintainable. So for example, I have this config dbts file, which is really just some code I put aside, so it's not muddying my main program. And here I'm pulling in config data from that prod.dev.yaml or Pulumi.dev.yaml or Pulumi.prod.yaml. And if it's not set, I can set it to a default. And here again, I'm able to leverage, in this case, TypeScript, inline conditional. Down here, I set a password. Well, if it's not set, I create one. And again, just a very straightforward use of conditional, but still using a declarative model. So let's see what that secrets part of the picture looks like a bit, right? So as Luke was saying, I can set secret sensitive data. And so I'm going to set that DB password. I'm going to actually provide one because in my dev environment, I don't want it to generate it. I just want to use the one I like to use because it's still secure, but it's but the idea is I don't, I can just use one I'm familiar with, right? And here, this is not what I typed in. This is the encrypted version. This is the Pulumi service providing that key to the engine here, to the CLI, to encrypt it, and then during runtime to decrypt it and use it. And that's great, right? So now, and I can store this right alongside my code in a public repo without any concerns. Now, the other aspect of as a developer, really what I want is a quick development cycle. I want to be able to work efficiently, quickly, not have to, go jump around to documentation when I don't need to. And again, since we're using a programming language constructs here, since Pulumi publishes our, these various SDKs in the given language, the IDEs just naturally know how to use them, how to leverage them. And so, for example, let's say I'm thinking, I want to add a bucket, and it's AWS, and it's S3, right? So I get all this lovely autocomplete. It's a bucket, great. I'm just going to call it goo. And I know I'm done. I know this will work. But then let's say I'm thinking, well, I know there's a property around deleting or destroying. Oh yeah, force destroy. Excellent. I'll use that. And I'll set it to 3. Oh, I'm getting an error, right? Because force destroy is a Boolean value, not a number. So all this just makes me super efficient. I'm able to just rip through and create my code. Not the word Boolean, Mitch, an actual Boolean. I'm able to be very efficient and really kind of get through this very quickly. Similarly, if I don't want to jump over to our documentation, I can, just as easily in context in my IDE, go to the definition, see, oh, these are all the various inputs I can leverage in that VPC call. And so I'll get rid of this. And let's do a Pulumi up, which you've seen a couple times today in various forms, whether it's on a command line or through our new deploy capability. And essentially, now it's telling it to go and update the stack. And the main update is really because I'm now providing a password. So it's going to destroy that resource and that password resource and just update the RDS with my provided password. And again, as part of an engineer, as part of a developer, I want convenience. I want ease of use. And so the service really provides me a lot of that. So first of all, I have my various important to me stacks starred here. I can quickly hop over to it. As we saw, I can see a full history of what's going on, including my current update. Within that update, I'll be able to see the changes that are occurring. Within a given update, I can see the commit ID, the branch it was run from. Later on, we'll see, we saw, if you didn't catch it, that in the deploy cases, there's a little rocket ship there showing me with a link to my deployment. In the case of a CI/CD pipeline, we'll see later, it'll take me to the CI/CD. When I look at the resources, I can easily get a quick link into the cloud provider's view so that I can see it. Now, this is not a case where we're leveraging your credentials to reach into AWS. This is just Pulumi providing you an easy link to get over there. I'm logged in, so I'm able to see the UI. So that basic dry around having a single program, instantiating the different environments, that quick development cycle that the IDE just naturally provides because we're using, programming language based SDKs, and the convenience of the UI is really the first level of making my experience all that much better. So I will turn it back over to Luke to
Awesome.
talk about teams.
Well, thanks, Mitch. Let me bring up the slides and we'll keep going from there. So for teams, when we think about kind of the things that help with team productivity and team best practices, one of the first things we really think about is components. And so, when we think about the fundamental benefits of software engineering, one of the really important software engineering practices is really creating new abstractions. One of the best things we can do with software is take some code that implements some functionality, abstract it out into a function or a component, give it a name, define the interface and document it for that component, and then allow the rest of the organization and the rest of the world to go build on top of that abstraction. And so components are really fundamental to how we think about what it means to use software. And traditionally, components and abstraction have been underutilized in infrastructure as code relative to other forms of software engineering. While in an application development world, we might grimace at the idea of copying and pasting large chunks of code around within our code base, that's actually more the norm than the exception in most infrastructure as code projects, is that we'll just go copy and paste 1,000 lines of HCL or YAML, and we'll paste it over here, and now we've got 2 copies of everything. And so with Pulumi, we get sort of the best-in-class tools for creating components and abstractions, built using the classes and functions and components that are available inside our languages of choice. And so we can bring those to bear on our infrastructure to gain this sort of don't repeat yourself, build abstractions, build on the shoulders of others. One thing that goes hand in hand with that is actually Pulumi's ability to have transformations, which mean that when you use a component, if it doesn't do exactly what you want, you still have the ability to go modify the ultimate results of that component in any way you want. And this is a really important feature because it means that components don't have to support every single potential form that they could be used in. They can decide what the high-level API is they want to provide, and then consumers, if they need to pierce through that abstraction, can do that using transformations. And so a really powerful way to get the best of components with also the best of infrastructure as code flexibility. Another key software engineering best practice that is traditionally underutilized in the infrastructure as code space is testing. And there are really 2 types of testing that we think about applying to infrastructure as code. There's unit tests, which are sort of fast and lightweight. They're written primarily to validate that the code we wrote is correct, that it wires together the different pieces of infrastructure in the way that we intended to do under all the different parameterizations that we might support based on configuration or based on the component that we're building. The other is integration testing, where we can sort of validate end-to-end correctness of our cloud infrastructure by actually standing up some cloud infrastructure, validating that it works, validating that all the network access is correct, that the database is wired up to the application tier, all these different pieces that are going to be necessary for a correctly functioning piece of infrastructure, and then tears it all down. Integration tests obviously are heavier weight, but they can be really easy to do with infrastructure as code because we have everything encoded as software and as code. We can spin up and tear down these stacks really easily to have really high confidence in our correctness. And lastly, it's really important with testing to think about not just testing our projects and our programs, the end result of building out one of these things, but also testing our components. As we build reusable components, we can test those components in isolation, make sure that they work correctly, and then leverage that as we go into using those in other parts of our application. The next piece here is sort of multi-stack architectures. And when we really think about best practices for software engineering, we often think about sort of microservices and breaking down our applications into units that sort of evolve along common boundaries. So where an independent team owns and versions a piece of software separately from all the other pieces. This helps to limit blast radius, helps to give teams more autonomy, and helps to ensure that versioning and the way that versioning relates across different parts of the application is not monolithic, but can actually be driven independently for different components that version separately. Now in Pulumi, we actually have the ability to have stack references, which mean you can do this breaking a stack up into multiple different smaller stacks, but still easily leverage the outputs of one stack as inputs to another stack and make sure that as we evolve these, we can take advantage of that. And then finally for teams, one of the ultimate things we want from our team is to be able to deliver value out to our customers and to our business really quickly. So we want to be continuously delivering not just our application software, but continuously delivering changes to our cloud infrastructure as well. And of course, we can use any of our existing CI/CD providers. If we've got that set up in our environment, we can go and put Pulumi into that environment and take advantage of the existing infrastructure we have. We could also do this through things like the Kubernetes operator, if we want to use Kubernetes as the control plane, Pulumi deployments, like we introduced earlier today, or the automation API, if we want to build our own custom software solutions around this. Any of these allow us to sort of automate the infrastructure delivery within our organization and make sure that we can deliver change really quickly and reliably into our production environment. And to show off a few of these, in particular components and testing, let me hand it back over to Mitch to talk about how teams can apply infrastructure as code best practices.
When we start talking about teams, one of the first aspects that come into play, and I'm still a developer, right? All the things I talked about a little bit ago still apply. But now we might enter a realm where there's a bit of, a separation of concerns, as Luke was talking about, or different teams, different cadences around different stacks and different environments. And that's where the multi-stack architectures really come into play. And so here, for example, I have a multi-stack architecture that consists of a backend. So the backend stands up a DynamoDB, Lambda, and an event bus using EventBridge. And then I have a front end, which is standing up an API gateway with a Lambda that drops data into that EventBridge, into the bus, and then on that backend part of the solution, pulls it out and puts it into DynamoDB. Pretty simple, but you can see that the backend team is going to be working at their pace, the front end team at their own pace, and so it makes sense to really have them as separate stacks. And so if we look at the code for the backend, we basically see creation of a thing called the backend and this bus, and we'll dig into that in a minute. And it exports as an output of the stack, the bus ARN, as well as some other data. But this is the important one for the front end team because they need to know how to write into the bus. And so if we go look at the front end stack code, we basically see this bit here where Pulumi provides the stack reference method, this capability to go and connect to that other stack and get the outputs or output that it needs. And in this case, it's that bus ARN output. And this is enabled very simply by the service. And the service's RBAC capabilities also play into this. So for example, I, as a front-end team member, don't maybe have update permissions to update the backend stack, but I have read permissions so I can get the bus ARN. Now, this is all enabled and leveraging component resources, these reusable classes. So earlier I had that sort of config DB file, which was just a file, just using sort of a basic TypeScript construct to put code into another file. But Pulumi also makes available what we call the component resource class, and I'll use the bus one as an example. So the component resource is an extension on class, and really what it allows me to do is capture my best practices around how I like to do things. It allows me to abstract away the details of how I like to do those things. And so in this case, whenever I want to create a bus, an event bus, I create an event bus, I create a rule, and I create a target. And that's, nobody else needs to know that really. I write this once and then the front end team or the back end team in this case gets to use it. Similarly, if there's another project, another application that needs to stand up a bus, they can just reuse this component resource. It can be published like any other TypeScript module in my Refactoring and pulled down just like any other TypeScript module. And so again, and I'm also able to control, if I'm like a central platform team, right, I can control what inputs I allow them to use and what outputs I present back. The input could even be like a small, medium, or large, right? And I just have the logic in here to decide what that means. As Luke was saying, there's also this idea of transformations. So coming back to my components folder here, I have this tagger file, which is really just capturing a function. So it's not a component resource in this case, but again, I'm able to leverage, the programming languages approaches around putting stuff into other folders, other files, so that I don't have to, again, muddy my code. And more importantly, I can write this once and use it all over the place. And in this case, tag all resources uses our stack transformations capability. Essentially, I'm able to pass the stack transformation properties, which are then applied across all the resources in the stack as I want them to be. So instead of adding this, so if we come back to my index here, I'm going to add a new tag called project name with a value, and I'm going to use my name base, which is just a sort of naming convention I came up with. And so instead of going through and updating all the actual component resource code, I can layer this on top of any tags they want to set. So at this point, if I do a Pulumi up, oops, maybe not all caps, this will go and essentially look at, again, what Pulumi does best, right? Which is understand what the current state is, understand the desired state, and apply those changes. Now, also as part of this team dynamic, right, I want to be able to test my code, and kind of even getting back to that sort of quick dev cycle, right? I want to be able to do unit tests. And again, since I'm using a programming language here for my infrastructure's code, I can leverage, the tooling and the capabilities and the processes that the language enables, such as setting mocks and then running unit tests. I can layer on top of that integration testing, as Luke had mentioned, around even leveraging our automation API, where I can orchestrate a whole, both of these stacks, and then run just using standard, packages for the given language to hit the API, test the API, return results. And of course, this all very naturally, organically plugs into CI/CD pipelines. I can have, I push a branch that creates a branch specific stack. It gets tested. When it gets merged into, say, my staging branch, that then pushes onto the staging environment, and etc. So separation of concerns, multi-stacks, dry part 2, these component resources that I get to write in these classes and then leverage throughout my code, throughout various projects and other bits of code, and then being able to run testing as I need to. So I'll turn it back over to Luke to talk about orgs.
So let's move on to organizations. So when we think about kind of organizations, one of the first things we really think about is how do we enforce policy across the organization. This allows us to have consistency in what we do across our organization and to enforce best practices for the things that we deploy. And so, this can be in 2 forms. One can be in the form of warnings, where we just let you know, the organization enforces some policy, but it's a warning, just to let you know that this is against our best practices, or that maybe you don't want to do this, and to provide guidance for developers kind of working within the organization. The other is errors, where we actually want to completely prevent you from doing certain classes of operations and using certain classes of resources. For example, we may want to completely prevent you from exposing a bucket to the internet unless you tag it with a very explicit tag that indicates you were doing that on purpose. We can use these policies to enforce lots of things, where they can be about compliance and security. They can also be about cost and providing just guardrails to encourage people to work within the sort of best practices that the organization has made sure are a sort of golden path for what folks do. Now, because this is just software, our policies can be as rich as they want. They don't just have to be these things that are very, very simple, constraints where no, you can't use this property, or no, you can't use this thing. They can actually look up data, so they can go and download an allow list or an inventory or a pricing sheet and use that as input to the policies. So it can be very, very dynamic, very software-based, and very rich for our organization. And of course, with the Pulumi service, we can go and enforce those across the entire organization and make sure that no one who builds a stack, or no one who builds a stack targeting a certain environment, is able to deploy things that don't match our policies. The second piece of sort of enabling consistency across the organization is leveraging sort of packages. And so just like with any other software ecosystem where we have reusable packages, whether they're in NPM or PyPy or NuGet or whatever my package manager might be, with Pulumi, we can build reusable packages as well. And those packages take a set of components and capabilities that are available to Pulumi and make sure that they have a cleanly versioned delivery of changes to that package, so I can pick up and deploy a specific version and use that and pin that for my infrastructure, and then adopt new versions when I'm ready to test and validate the compatibility with those changes. They also allow me to publish into the Pulumi registry, so they get rich documentation and support for those libraries. And finally, they allow me to go and ultimately publish those packages into my favorite package manager, whether that's my own Refactoring for internal usage, whether it's into some public package manager like the public NPM or PyPy, or however I want to distribute my packages. And finally, for organizations, one of the things, another kind of core software engineering benefit is really thinking about refactoring. And refactoring is so valuable for software engineering because it means that as we evolve and manage a code base over a long period of time, we can evolve that code base to sort of continue to represent what the organization intends this code to do. As the names of things change, as the boundaries for where abstractions make sense change, and as the capabilities get more and more advanced for infrastructure, we typically want to make changes to the way that that code is laid out, the way that resources are represented, and the different pieces of infrastructure that are being managed. And so refactoring is just as important for our cloud infrastructure as it is for application code. And in Pulumi, we have rich support for refactoring, not just at the level of using all the refactoring tools available for your programming language of choice, but also at the infrastructure as code layer. And traditionally, infrastructure as code has presented a little bit of an additional challenge for refactoring because it's not just the code that has to change, it's actually the state. And so because you can have different instances of your stack in different states with different state files, we need to make sure that we can evolve changes across the different versions of how this has been represented in your state in the past. And so Pulumi's aliases feature is actually designed specifically to make sure that it's really easy and possible to refactor cleanly your components and your projects that you deploy using Pulumi. And this allows you to apply aliases, for example, to components to enable backwards compatible migrations. As we make refactorings to how a component works or changes to its behavior, we can easily make sure that those don't break existing applications and don't require them to replace existing resources. So for one last demo, let's take a look at how organizations can take advantage of policy and packages in Pulumi.
Now at the organization level, it gets, sort of dry part 3, as I like to call it. You might even, we might even be at a point where the organization is wide enough and large enough that there are different teams handling different pieces of infrastructure, even in different languages. Similarly, getting to that package concept, I can create things in one language and share them across. So let's look at what I have here. So I have a I'm at a sort of a 2-stack, multi-stack architecture where I have my base infrastructure. This is standing up an EKS with a VPC and what have you. It's written in Python because the team that manages the infrastructure like VPCs and EKS wanted to work in Python. Not a problem. And so they deploy this. They have this deployed in Python. And one of the key aspects that that comes out of this stack is the kube config for the EKS cluster. And here I'm actually using an inline secrets to be able to make sure it's treated carefully by Pulumi. Again, once something is marked as a secret, whether it's an input or output, Pulumi does not leak it into logs or state or anything like that. And then the application team, which deploys the guestbook app, if you will, is writing it in TypeScript. Not a problem. And it's going to use, and it is using that same stack reference construct I talked about a few minutes ago, where it's going to pull the kube config and instantiate the Kubernetes provider. And so basically what that, so at this point, I'll push deploy the application, the guestbook app. And while that's running, we'll dig a little bit more into what's going on here. One of which is that this service deployment construct here, this module, this resource, is actually based on a multi-language component, a multi-language package that is written by us, by the team. In this case, I'll say it's me, just to kind of make it simple and understandable. And this package, this component, is actually written in this case in Go. But it's just a component resource at the end of the day, just like we saw earlier with the front end and back end with the bus and the different component resources there that were written in TypeScript. This one just happens to be written in Go. And through our multi-language component capability, you'll see it also noted as crosscode. I'm able to generate SDKs for all the different languages that we support. And so the app team is able to use that to deploy these Redis modules, service and deployment. So in this, I've kind of taken it to the nth degree around dry and reusability and being able to work in different languages. But essentially, I have my base written in Python, my app written in TypeScript using a module that was originally written in Go, but has been able to be just built into the different languages without any extra work to rewrite or anything like that. Now, you'll also see here some policies firing. So these are advisory, so they can be either advisory or mandatory. Advisory means I get yelled at, but I'm able to proceed. But in this case, so I'm allowed to proceed. And this is coming from the service. So the service has the ability allows me to publish what we call policy packs. They can be put into policy groups. These policy groups are then applied to stacks. And if they were set to mandatory in any of them, I'd have been stopped dead in the water. Similarly, at the organization level, I want to be able to manage my teams and my membership through single sign-on, including SAML and SCIM. So I'm able to create teams that have read permissions for stacks, write permissions to other stacks, no permissions whatsoever. And also as an organization, I want to have audit logs to be able to see everything that's going on. And just as before, able to see, all the activity for any stack at any time, including, events coming out of CI/CD.
Wonderful. Yeah, I think one of the most important aspects of Pulumi at the end of the day is sort of the benefits that it can scale across all of these, from individual developers to teams, and then ultimately up to large organizations applying infrastructure as code at scale. Just to recap, I think when we really think about infrastructure as code best practices, what that means for us at Pulumi and has meant since the sort of beginnings of the Pulumi project is really meant applying software engineering best practices into how we manage cloud infrastructure. And we've seen today how we can do that across many of these different areas, from developers and code and how we can leverage productivity at that level, to teams and how they can manage quickly delivering software, having reusable components and testing those, and then how organizations can enforce consistency across their best practices. So that's it for Mitch and I. Coming up next, we're actually going to transition into two sessions, one here in the main stage and one on the customer stage. Both of these sessions are going to be with Pulumi customers who are building really interesting things on top of Pulumi.